Both module timer programming. 8051 has two timers, timer 0 and timer 1, and both are 16 bits wide. So we know that 8051 is a 8-bit microcontroller. So since it's an 8-bit microcontroller and timer 0 and timer 1 are 16 bits wide, it will be designated or it will be referenced to as the lower byte and the higher byte. Okay, so separate registers of low byte and high byte. So how do you designate it as low byte and high byte? By TH and TL. So this is the timer 0. TL0 is the lower byte of timer 0. TL1 is the lower byte of timer 1. TH0 is the higher byte of timer 0 and TH1 is the higher byte of timer 1. So each TL0, TL1, TH0, TH1 all are 8 bits long. So D0 to D7 of timer 0 is TL0 and D8 to D15 of timer 0 is TH0. Likewise, D0 to D7 of timer 1 is TL1 and D8 to D15 of timer 1 is TH1. So you can write in the program each byte wise also. Like just like you would write a register inside a program in a particular instruction, just like that you can address the TH0, TH1, TL0, TL1 inside a instruction. So if you write move TL0 comma hash 4fh, that means that the value 4f is moved to TL0. So TL0, this will get 4f. So that will be 0100111111. And move R5 comma TH0 means whatever value is there in TH0, that will be moved to the register R5. So you can use TL0, TH0, TL1, TH1 just like a register inside an instruction. You needn't only refer it to as a 16-bit register. You can use it as 8-bit registers. So both timer 0 and timer 1, we know that there are two timers, timer 0 and timer 1. So if you want to, you have a timer mode called the T mode to set the various timer operation modes. So what are the timer operation modes and how do you set the timers to operate in a particular mode? So that we'll see here. So T mode, unlike the T0 and T1, T mode is 8-bit. So T mode, it is 8-bit, so 4-bit, 4-bit. The lower order 4 bits is for timer 0 and the higher order 4 bits is for timer 1. So this together forms the T mode. So T mode, why do you have T mode? You have T0 and T1, those are two timers. In order to fix a particular mode of operation for the timers, you have the T mode register, which is 8 bits long. So low order bits for timer 0 and high order bits for timer 1. So what do you have in these 4 bits? It is the same. The low order 4 bits and the high order 4 bits are the same. Only difference is that the low order is for timer 0 and the high order is for timer 1. So you have M1, M0 which will set the mode. You have gate and C bar T. Now we'll see what these are. So the low order 2 bits, it is to set the timer mode M1, M0. So M1, M0 can have 0001110 and 11. So those will set the timer modes. So let's see the timer modes 00011011. So simply you can say it is 0123, mode 0123. So what it actually does is this, that is, if it's in mode 0, it will act as a 13-bit timer mode. If it's in mode 1, it will act as a 16-bit timer mode. 2, it acts as a 8-bit auto reload. 3, split timer mode. Okay, so that is what, just for now, we'll say it is 0123, mode 0123, depending on which is the, what are the bits in M1 and M0. So if this M1, M0 you are referring to is in the lower order 4 bits, then timer 0 is in this particular mode. If it's in the higher order 4 bits, then you can say that timer 1 is in this particular mode. Now you have two more bits in these two nibbles. One is the gate and one is the C bar T. Now coming to C bar T, C bar T is counter bar timer. So if the C bar T value is 0 cleared, then you take the input from the internal system clock, that is the crystal frequency, and it is uh, acting as a timer. So if it's 0, then it is acting as a timer. And where will you get the input frequency? From the internal system clock. If it is 1, C bar T, if it is 1, then it will act as a counter. So it's either a counter or a timer. Timer when it is 0, 1, then it is acting as a counter. So if it's 1, C bar T, if it is 1, it will act as a counter, and the input, what you are going to count, the input is from the transmit input pin of the 8051. So 8051 has a TX or the transmit input pin. So there you can give the input, and that will be counted if you are setting C bar T as equal to 1. If C bar T is equal to 0, then it will be acting as a timer, and the input will be taken from the internal system clock. Now gate. Gate is another bit, the MSB bit, and here the fourth bit, 0, 1, 2, 3, 4. 0, 1, 2, 3, sorry, D0 and D7. So gating control when set, timer or the counter. Timer or the counter depends on the C bar T value. So whatever it is enabled only if the INTX is the interrupt pin. So 8051 has two interrupt pins, INT0 and INT1. So if INTX, that is INT0 or INT1, if the INT pin is high and the TRX control pin is set, so these we'll see later on. So this is the TRX pin. So this is another register of the timer. Just like TMOD, you have another register called the TCON register. So TRX means these two bits of the TCON register. Okay. So just understand that there are two bits here in this register, so, and TRX just means these two bits. So the TRX control pin is set to 1 and INTX pin is high. Then the timer or counter, whatever it is enabled. And when that happens when gate pin is 1. So if gate pin is 1, then the timer or counter is enabled. So for the timer or counter to be enabled, the gate pin should be 1 and INTX pin should be high and the TRX control pin should be 1. If gate pin is 0, then the timer is enabled, not the counter. Timer is enabled if TRX pin is 1. Okay. So that is the TMOD register. So you'll have to know what a TMOD register is, what are the pins or what are the bits in the TMOD register, how do you set a particular mode, what does each of the bits signify, what are the two types of timers, how can you address these two timers, etc. Now here we have uh, a problem which is indicate which mode and which timer are selected for the following. So move T mode equal to 0, 1. So T mode we know you have 8 bits. The higher order 4 bits is for timer 1 and low order 4 bits is for timer 0. So you have gate C bar T M1 M0 for timer 1. Then gate C bar T M1 M0 for timer 0. Now, what are you moving to T mode? It is 0, 1. So, 0, 0, 0, 0, 0, 0, 0, 1. So, 1 is for the timer 0, M0. So, M1, M0 of timer 0, we know that it is 0, 1. So, that is mode 1 of timer 0. So, here, if you see, what are you going to give? 0, 0, 0, 0, 0, 0, 0, 1. So here it is 0, 1. So it is timer 0. Timer 0 gets a mode 1. Here all are 0. So we are not going to talk about the timer 1. So if you want to talk about the timer 1, then it is in mode 0. So mode 1 of timer 0 is selected. Next is 20. So 20H means what? 20. So 0010. So 10 here means mode 2 of timer 1. 20. So all these are 0. So we won't talk about timer 0. It is timer 1 in mode 2. Next is 12H. 12H means 0001, 0010. So 0001 means timer 1 is mode 1 and timer 2 is in mode 2. So you can have multiple uh, modes for both the timers or mode for only one timer. Okay, depending on the value you are going to move to T mode. So this is mode 2 of timer 0 and mode 1 of timer 1. So you can find that out. Next is find the timer's clock frequency and its period for various 8051 base system with a crystal frequency 11.0592 megahertz when C bar T is of T mode is 0. So if C bar T is equal to 0, we know that it is used as a timer. If C bar T is equal to 1, then it is used as a counter. So the clock source for a timer, we said that it is from the crystal frequency of the uh, clock. Sorry, crystal frequency. So that is 11.0592. So that is anyway given in the question itself. Otherwise, you can assume it like that. So in the case of a timer, always it is 1 by 12 the clock frequency. Okay, so crystal oscillator is divided by 12, and that will be the clock frequency of the timer. So that is a constant in the case of 8051. So it is always 1 by 12th of the clock frequency. So you'll get the clock frequency from the crystal oscillator, and 1 by 12th of that will give you the timer clock. So that is 921.6 megahertz, and time will be 1 by this. So that is 1.085 microsecond. So just understand that it is always 1 by 12th of the clock frequency for the timer. So how do you start and stop the timers of 8051? So in order to start and stop, you can use either software or hardware control. If you are using software control, then just make gate equal to 0. And the TR we saw just now, TMOD register has 2 bits called TR0 and TR1. We'll come to that later on. Just understand that there are 2 bits TR0 and TR1, and the start and stop of the timer are controlled by the way of software by TR timer start bits of TR0 and TR1. So if you are giving set bit, then it will start, clear, it will stop. So we'll come to that instruction later on. Just understand that set bit will start the timer and clear will stop the timer. So this will happen as long as gate is equal to 0 in TMOD register. So that is the software part. So how do you start and stop a timer using software in 8051 using the instruction set bit and clear. Set bit and clear what? The TR0 and TR1. Now when does this work? It works when gate is equal to 0 in TMOD register. Now the hardware way of starting and stopping the timer is by an external source. So for that, gate should be equal to 1 in TMOD register. Now we'll come to a problem. Find the value for TMOD if we want to program timer 0 in mode 2. Timer 0 in mode 2. Timer 0 in mode 2 means timer 1 is not in picture. So timer 1, the higher order 4 bits will be 0 and lower order 4 bits will be 2. So it will be equivalent to 0, 2. So TMOD will be 0. Now the latter part of the question will go in detail. So use instruction to start and stop the timer. So we know that it's a we are dealing with mode 1 programming. So mode 1 programming. So it's a 16-bit timer. So 16-bit timer means what? It is 2 bytes. So 0000 to FFFF can be loaded into the timer register, timer 0 and timer 1. that is TL and TH. So after TL and TH is loaded with a 16-bit initial value. So first you load an initial value into TL and TH. 16-bit value is loaded into TL and TH together. The timer value is loaded. Then the timer should be started. So how do you start it? We said that it is started using the set bit and stopped using clear bit. So set bit TR0 for timer 0, and if you are using timer 1, then set bit TR1. So it is ACTB TR0 or ACTB TR1 to start. After the timer is started, it starts to count up. Okay. So this is the arrangement. So you have the crystal oscillator. We know that if it's acting as a timer, then the frequency which we get for the timer is 1 by 12th of the crystal frequency. So that is what is shown here. And since this is acting as a timer and not a counter, the C bar T will be equal to 0. So this frequency comes here. You have an AND gate and TR, the TR value, that is whether you are going to set TR or clear TR. So that value will come to the other input of the AND gate. So here you have the frequency. If this is also equal to 1, then that frequency will go to the output of the AND gate. And if there is a output at the output of the AND gate, then this timer will start to count. So from where to where, whatever value was initially loaded into the timer, that 16-bit value, TL and TH, from there it will start to count. So that is why we initially load a particular value into the timer. So first timer is loaded with the value, then we'll give set bit TR0 or TR1 depending on whichever timer you are using. Then it will start to count up. So count up from the initial value. So initial value, from initial value, it will count up to where? It will count up to FFFF. So it has reached the maximum value FFFF. So one more clock pulse when it reaches, then we know that the counter, it will, next count will be 0000. So this is equivalent to high to low pulse, FFFF to 0000. So that is the maximum value possible for this particular counters FFFF. One more clock pulse comes, the next value will be 0000. So you can say that it is a high to low pulse. So when that happens, that what does it mean? It has completed the counting. So if more clock pulses come in, then you are going to the next cycle of counting. Okay, so this particular counting sequence has ended. We are going to the next sequence. So that particular intimation comes when there is a high to low pulse, that is FFFF to 0000. When that happens in the timer, so when that particular case appears, you have a TF flag, which is called the overflow flag, timer overflow flag, that will be set to 1 when the timer goes from FFFF to 0000, FFFF to 0000. It sets higher flag bit called the timer flag or the overflow flag. So timer flag, it has TF0 and TF1. There are two types of timer flags. One for timer 1 and one for timer 0, and this timer flag we will analyze whether it is going to 1 or not. It will go to 1 when the timer counts from FFFF to 0000. So when this incident happens, we know that one cycle has completed and the other cycle is yet to begin. So when TF becomes equal to 1, so you can either stop the counting by giving clear TR0 or clear TR1, whichever timer is now counting. Or if you want to repeat the process, that is, if you want to continue the counting, then uh, you must reload the TH and TL with the original value. So initially we had entered some value to TH and TL. That value should be again reloaded if you want to continue the process. Okay. So this is what happens in the timer operation in the mode 1. First, TH and TL is loaded with an initial value. Then you will make TR equal to 1 by set bit TR0 or TR1, whichever timer you are using, 0 or 1. Then a clock will be given to the timer so that it will start to count from the initial value which you have loaded. It will count up to FFFF. After that, it will go to 0000. So when that incident happens, when it goes from FFFF to 0000, the timer flag, you have two timer flags, one for timer 0 and the other for timer 1. That will be set to 1. Whichever timer you are now using, that particular TF flag will be set to 1. So when you see that, either you can stop the counter by clearing what? Clearing TR, CLR TR0 or CLR TR1. If you want to just stop it. If you want to continue the process, then what you will do, you will reload TH and TL with the original value and then continue the process. So that is mode 1 programming. Now next is to generate a time delay. So everything, all these in mode 1 programming itself. If you want to generate a time delay, then load the TMOD register indicating which timer is to be used and which timer mode is selected. So you'll select a particular mode for a particular timer, either timer 0 or timer 1, and what is the mode of operation. Then again TL and TH is loaded with the initial value. Start the timer by set bit. Keep monitoring the timer flag TF with jump if no bit TFX. TFX means TF0 or TF1, whichever timer you are using. So you can see if this is set to 1 or not using this particular instruction. So whenever it is not set, it will go to a target instruction. If it is set, then it will go to the just below instruction. So unless it is 1, it will go to the target means what? It will continue the loop. The loop is executed continuously until TF becomes equal to 1. When is TF becoming equal to 1? When the timer counts from FFFF to 0000. So get out of the loop when TF is equal to 1. Stop the timer. Clear the TF flag for the next round and go back to step 2. That is, reload with the actual value. So that is how you create a delay. So load it with a value. Select the timer mode and whichever timer. Start the timer with set bit. Analyze TF using jump if no bit TFX comma target. And once TF is equal to 1, get out of the loop. Stop the timer. Clear the TF flag and reload the value, initial value. So next program is create a square wave of 50% duty cycle. We know what 50% duty cycle is. T on is equal to T off. High is equal to low for a square pulse with equal portions high and low. That is what is 50% duty cycle on P15 bit. So how do you do it? We have done this program before by just complement P15. P15 first, if it is 0, next time it will be 1, next time it will be 0, that will continue. Timer 0 is used to generate the time delay. So time delay, how is it generated? We have shown the different steps to generate the time delay. So here the program is given, just analyze the program. So TMOD is given 0, 1. So the first step was load the value into TMOD so as to select a particular timer and a particular mode of operation. So TMOD equal to 0, 1 means timer 1 is out of the picture, timer 0 is in the picture, and the mode of operation is 0, 1. So we have selected timer 0 with mode 1. Then load TL and TH. So here TL is timer 0, so TL 0 and TH 0. So it is loaded with a value. This is just a value we are giving. So you can load it with any value. So TL 0 is given 0F2 and TH 0 is given FFH. So we know that TL 0 and TH 0 both are 8 bits each. So what is timer 0 total value? It is FF, F2, TH0, TL0. Yes. Now complement P15, then caller delay. So P15 is complemented, a delay is called. So you'll go to a subroutine which will have a delay program. Then when you return, then again execute this instruction. So what is happening here? Just what we said in the earlier section, how to create a delay. Load TMOD with a value for selecting timer value and the mode. Then TH and TL is loaded with a value. Then here some operation is done, CPL 1.5. Then we are going to continue this loop after a particular delay. So this is what is told here. So this is the delay program. So in the delay program, what we are doing, how do we create a delay program? We told that is we have to set bit TR0, then analyze TF0, and until and unless TF0 is equal to 1, you have to be in the loop. So you have to be in this loop. Once TF0 is equal to 1, that is FFFF to 0000, then it goes out of the loop, clear TR0 and clear TF0 and then return. So this is just as the algorithm goes. We have written the program. So here we have we had loaded it with FFF2. So when the timer counts up, it goes through the states FFF3, 4, 5, 6, A, B until FFFF. And after that, it goes to 0000. After this, clear TR0 because TF equal to 1. So TR0 is cleared, TF0 is cleared, and repeat the process. So this is mode 1 programming, how to create a delay.